Hello, everybody. Welcome to our final session. We have another workshop coming next week. This is our final session, and I'm joined by Chris. We're going to go ahead and I'm gonna hand it off to Chris and get started because we got a lot to get through. So, welcome in, Chris. I'll stick around for a second while you introduce yourself, and then I'll drop off and start answering questions for people. So, welcome in, Chris. What do you got for us today?
Hi. If the clicker works and it advances the slide, it's gone to sleep. Hang on. Maybe. Slides. Hang on. There we go. Right. Cool. So to kick things off, hi, my name's Chris Nesbitt-Smith. I'm based in London. I currently work with some kind of well-known brands like Learncates, Control Plane, and various bits of UK Gov. I'm also a tinker of various bits of open source stuff. I've been using and abusing mostly Kubernetes in production since it was 0.4. So I've got some war wins to show for that journey. Should have plenty of time at the end for questions and of course your best heckles. But if we run out of time, or if you're not watching this live, then please come find me on LinkedIn or on the Loft Labs Slack. Right, let's get going. So I'm going to spend a bit of time talking about security in the context of multi-tenancy, and I'm going to use a case study for that. So I will caveat that though with that I base this entirely on the publicly available information. So I'm likely way off the mark on many of the points if there's anyone actually from Gitpod watching this. But I'm going to talk about them in a way that's, and there's much smarter people there than I could come up with for innovative solutions, but still gives us something reasonably relatable to kind of point and talk at. So with those caveats and disclaimers, let's get out of the way and let's dive in. So if you've not used Gitpod before, just a scene set, you can try it quite simply by going to your favorite GitHub repository. And by simply prefixing the address with gitpod.io, it will take you through to a fully fledged development environment, much like GitHub Spaces or Amazon's Cloud9, if you've used either of those. Gitpod's open source is a differentiator to that, so you can run your own instance in your organization if you want to, which might be particularly useful if you're in a regulated environment where you might otherwise have ended up using, say, a virtual desktop infrastructure or VDI for your development environments. So the interface should feel very familiar to anyone that has used Visual Studio Code or any of the forks of that. And you get a fully dedicated environment dynamically provisioned for you with a full IDE and all the tools and plugins that you're used to. So this should probably run some shivers down the spines of anyone beginning to think that the security implications of basically giving all of your users the ability to execute arbitrary code on your remote server and not let one instance of that affect another. And that's just within a single organization with a single trust boundary. If you can imagine the horrors of providing that publicly on one giant Kubernetes cluster. So the architecture for Gitpod is pretty simple. If we take a look, we'll see a familiar looking Kubernetes cluster. And if we deploy Gitpod, each instance of a user's development environment in this context is a pod on the cluster. And if we were to look inside a Gitpod pod, we'd see something along the lines of this, with a single container running multiple processes. Arguably a bit of an anti-pattern for Kubernetes purists, where you might expect to see a more microservice-like architecture, with a single process running in each container and pods being one-to-one mapped to the containers apart from the sidecars. But why run it this way? Well, because Gitpod is multi-tenanted, each user needs all of the resources for their environment locally. It also needs to be portable to run on environments that work quite like Kubernetes, that allow you to compose pods. So the complexity would be even more unwieldy if you were to run something like this for every instance. So you might wonder why I'm even talking about Gitpod, especially if you've followed the news, where they publicly declared they were leaving at Kubernetes after a relentless 6 years of trying. Well, they highlight some of the challenges they were facing and the complexity of the architecture, and give some clues that are interesting to dissect around resource management, security, and networking. So let's step through some of those, starting with resource management. So containers have requests and limits, which allows your application to live anywhere within the range up until the limit. When it's lower, you're still using all of the CPU and memory requests since those are guaranteed to the process. So if you allocate a large amount of memory, but your app uses a fraction, the rest is wasted. No other process is allowed to use that memory. Over allocating requests is a defensive strategy, but you end up paying for the resources that you don't use. An ideal scenario where memory and CPU consumption are close to the actual request value. When you define a request that's lower than the actual usage, your app will use more resources than what's guaranteed. If all apps are under allocating requests, the node will often be overcommitted, and the kubelet will be forced to evict pods to maintain a reasonable amount of memory available. Overcommitting could also trigger the autoscale more frequently, leading to nodes being provisioned and then destroyed. This can present a challenge when you are trying to minimize cost while still providing a good experience for your users, not allowing them to impact one another. Since the shape of a user interactions in this case will be very spiky, especially if they're just using IntelliSense or building, compiling, running tests, or maybe even just linting. So all your load will be very bursty, and you'll likely find yourself frequently and unwittingly exhausting your resources, exhausting the node, evicting pods, and probably triggering the autoscaler. Consequently, you're left between pretty much a rock and a hard place, between a terrible developer experience and paying well over the odds. Well, we've got some options here. So the completely fair schedule, or CFS, is a Linux thing that you can use to give processes priority over one another. If you've ever used nice or renice before as a Linux user, then you'll understand the concept. However, it is very hard to manage and it's quite low level. Then they tried to do dynamic resource allocation, which is basically adjusting the requests and limits on the fly, something you'd typically have to redeploy the applications to, since they're immutable properties on the pod spec. But that didn't really work for them because they can't really move the pods without disrupting the user experience, since they're anchored to the node for storage. And then you could use swap memory, which allows you to allocate more memory than you physically hold by using swap space on the node, which kind of works, but is inherently slower than actual real memory. So those are all quite involved, but what are your kind of normal options though as a normal kind of person? So in Gitpod scenario, this developer experience looked like slow IntelliSense, slow builds, tests, and lints. But in a more traditional application development scenario, these are more likely to present themselves as latency. So, for example, API calls to an external service and other processing, maybe some machine learning or AI. So your P99 latency is going to be less predictable, causing frequent scaling up and down. Of course, you could pay more, which is what most people do. And we are generally, on the whole, kind of as a world, gravitate towards that. But that is a cost, fundamentally. By overspecking the requests, but in that there will always be some CPU and memory that is not used. So if this is what our world looks like before, we can increase the requests and accept that we're going to be wasting a bit of money just to give us some headspace. The other option, of course, is you can allocate a whole node, which is probably more extreme. So to plot that a bit, if we oversubscribe on resources, we're getting cheaper with some risks, but reasonably manageable. Or we can go fully isolated, where you don't have an issue with noisy neighbors, but it is very expensive. There is an option in between, which is adjusting the requests and limits on the fly, which gets us a bit cheaper. There are tools that will do this for you that will basically track usage, analyze the data, and depending on your configuration or risk tolerance, will adjust the numbers on the fly for you. There are a few tools to do that, like StormForge, Perfect Scale, and Cubex, but in essence, they all do roughly the same thing in this context. The second problem that they talked about in the blog with Gitpod was network complexity, which was by far the biggest problem for them. So they have loads of environments and they want to spend the absolute minimum running them. They need to be super lightweight. Naturally, developers, you want to make sure they can't touch one another's instances. Well, there's network policy for that. So Gitpod is exposing a bunch of ports, which you'll obviously need if you're developing an application. You'll want to expose your work to the outside world somehow. Naturally, Kubernetes answers this with a service, which means a service for each pod. At the beginning, they started with an ingress per pod as well. However, found that didn't scale well and caused lots of traffic to move unnecessarily around the cluster. So if I have all of these tenants and they all need their own dedicated ingress controller, the cost is going to increase, and I will need more resources to run these pods. They then tried a single ingress controller, like you might be more used to seeing, perhaps. However, that presented the issue that they had too many services, which isn't a thing you very typically see in most ordinary situations running regular web services, which you can help a bit by disabling the service links configuration in the pod, but they still got to a point where DNS was failing. So it's worth a brief recap on how services in Kubernetes work. If we start with a cluster that looks like this, and we go and create a service, the controller manager creates the endpoint object and populates it with the IP address and port pairs from the pods. kubeproxy is a helper component that lives in the cluster and subscribes to changes, which will then update the IPVS or IP tables rules on the nodes, with the intercept and rewrite rules on the nodes, and in this case, 3 kubeproxies will write the same rules 3 times. At the same time, core DNS will also be notified, and DNS entries will be created or updated accordingly. So where are the issues? Well, it turns out if you have a few thousand services in a cluster, managing these IP tables can become slow and problematic, resulting in multi-minute delays on propagation of service information. And with service links enabled, as it is by default, every pod is going to have an awful lot of environment variables in scope. So with 5,000 services in a cluster, you would be able to expect 10,000 environment variables at least, most of which hopefully won't be actually accessible because they'll be blocked by network policy. But if nothing else, it's nothing else, just revealing a lot of what else is going on in the cluster. But why is core DNS so slow? Well, it's not entirely clear from their write-up, but you can imagine that if you've many pods doing DNS lookups, this could easily overload the internal DNS resolver. So what are your options to sharing resources? So generally, you follow the normal Kubernetes way of doing things and avoid having a dedicated thing for everything and share some common resources. Gitpod did network policy to create isolations, which is a great start, and you can very rapidly do the same. By default, of course, all pods in the cluster can talk to any other pod. Network policies are a Kubernetes native object that gives you the chance to define rules for your internal network. For example, you might want to control all the outbound or inbound traffic for a namespace. So let's take a look at the example. In this particular scenario, we want to limit the inbound traffic to the back-end API server. In particular, we want to make sure that the front-end component can issue API requests. The authentication service cannot issue API requests. We can define a network policy that is just another YAML file. So let's look at all the environment variables that are created for each service. So we can disable the service links at a pod level, which prevent them from being created. As a sidebar, Kubernetes has paid my bills for a while, but I absolutely loathe the inconsistent naming of things like this. Nowhere else in the API at all can I find it naming properties like this, but we're now stuck with it forever. Rant aside, setting this to false will prevent the environment variables being created. So no longer will there be 2 environment variables for each service port. This only ever existed to provide a consistency with Docker Compose. Do drop a message in the chat if you're using this, though, for real, or just tell me your favorite API bugbear. I'd love to hear them, and we can collect them. And then when it comes to IP tables limits, let's have a look at the current state of play. In this cluster, the purple pod makes a request to the type cluster IP service. Now we know that the service doesn't really exist. The IP is actually just a placeholder. As soon as the request reaches the network interface, it has to be intercepted and rewritten. We pretend to pretend that the IP address actually exists. So the request is changed on the fly, and the right pod is selected as the destination. We're now back to a pod-to-pod scenario, which of course has to work since the first rule of Kubernetes networking. So the request is changed on the fly, and the pod selected as the destination. We've described IP tables here, but of course, that's not the only technology that you can do to that. So many things like modern service meshes use eBPF as a trendy new, but actually pretty old technology for doing this. But what about the DNS scaling thing? So what can we do is rather than every pod hitting the core DNS service with every single query, if we see that core DNS is getting overwhelmed, we could potentially run a daemon set that would intercept the queries and provide a local cache. If when it gets a cache hit, it can return the result locally and only hit the upstream DNS if there's a cache miss. Though you'd have to naturally be careful to prevent any cache poisoning within the node. However, in the first scenario where core DNS is shared, if one of your tenants is creating more queries than the others, you've got the possibility for one tenant to impact others, which is not an unreasonable thing to happen in the real world. Core DNS provides some policies that you can apply, which can act as a kind of firewall to at least limit some of that traffic. Obviously, friends don't let friends run service meshes in production, but what if you've got bad friends? Well, you might find yourself taking your simple vanilla Kubernetes cluster with simple networking and adding a service mesh to it with lots of extra proxies and benefits like more containers and processes running than you ever wanted. Another thing that you'll have to feed and water. But it does allow us to define some policies. And you can define that. You can define how the traffic is allowed to flow through the extra complexity that you've created. The last one is workload isolation. So the other issue they had was that if they had a pod running, which are developer environments, so they'll want to basically have root access to the pod because you'll want to do stuff like run on privileged ports, install things, and so on. Breaking your own pod and maybe others near you is fundamentally a problem. But it comes dramatically more worse in a hurry if they can start taking over the overall node and then the cluster. And a kubelet takeover can often become a rapid route to total cluster takeover, which is a very bad thing for someone trying to provide a trustable multi-tenanted cloud developer environment. So Gitpod solved this in two ways. One is they use Kubernetes user namespace, which is a beta feature still not currently generally available. The other is sandboxed runtimes. So let's take a look at the user namespaces to start with. You basically run the pod as root with user namespaces. It uses namespaces in the Linux kernel that will map root to any other user on the host node, which gives you the illusion of running as root. You can, in general, run anything you'd like, but you are contained. And then sandbox runtimes. So if you remember like how the interfaces in the kubelet work and how they are used to create a pod, most of the time we create containers. We use a container runtime interface, or the CRI, which is usually container D by default, which will pull the container image and then run the pod. But of course, it's modular, and we can swap out container D for something more, for something compatible like Firecracker, or your cloud provider might provide a hyperscaler plugin, which will then fundamentally run a lightweight VM, which is in this case basically has VS Code inside it, which isn't necessarily a bad idea, but it isn't what they did. So what can we do instead? So you can mitigate the risk by reducing privileges in the container. You can set the security context on the pod or container level to restrict what a pod or container can do. Most of the time, you want to make sure that there are no privileged pods and the container does not run as root. Also, be careful what capabilities you do assign and only choose the ones you really need. For example, netadmin on the screenshot is usually not needed, so only add it if it is needed. The other option you can have to run containers is with a stronger isolation. There are two kind of key projects in this space, which are gvisor and kata containers. The general idea with processes in the Linux world is that every call, such as reading from the file system or using the network from your application, is dispatched to the kernel. Well, with gvisor, all of those calls are proxied, and you can then set policies on the syscalls of what the containers are allowed to do. Kata containers takes a slightly different approach to try to solve the issue by running every container in a lightweight VM instead of filtering on the syscalls. There are alternatives such as running using a cloud hyperscaler, Firecracker, Adira, WebAssembly, TinyKVM, and others all take a similar-ish approach. There is a lot of kind of current innovation in the space, so it's worth keeping an eye on if this sort of thing's interesting to you. If you play back the talk that Salman did a couple of weeks ago, and I strongly recommend you do, his talk was basically that so long as it's compatible, you maybe don't need that strong isolation for your non-production workloads, but you might want a more strong isolation for your production workloads. So please do go watch that if you've not seen it already. But what about security then? So I've spoken to you about how sharing the cluster between various teams, well, what about the security in this scenario? Let's explore how we can apply that to start with. Since there's zero overhead, it's a useful baseline. Let me present to you what Daniele presented in the first webinar. On the very left, we have the namespaces for multi-tenancy, and on the very right, we have a dedicated cluster per workload. Within the spectrum, there are options that give you varying levels of isolation to trade with cost and complexity overhead. It's unlikely to be a situation where you can just choose one. You'll likely have a mix of solutions and configurations of those to suit your needs. But as I said at the start, Gitpod ultimately concluded that none of these were suitable for them. So you should always keep in mind that rather than trying to force with that Kubernetes is the answer, what's the problem mentality, there are other ways to do things. If you're able to understand what kind of constraints you have and what goals you want to achieve, you can begin to evaluate what kind of tooling you might need. And it's important to do it this way around rather than starting with solutions and looking for a problem. Aligned to that spectrum, looking back at Daniele's talk, he spent some time mapping some of those tools to that spectrum in order to segregate tenants. He gave a great overview of a comparison of soft multi-tenancy versus hard multi-tenancy and everything in between. He gave an evaluation of namespace-based things with virtual clusters and their dedicated cluster approaches. Criteria for selecting the most appropriate multi-tenancy strategy, and a comparison of tools such as vCluster, Capsule, Kamaji, KCP, and K3K. What I'm going to focus on, though, is really just the left-hand side, as dedicated clusters is super hard. So you can see that we have a few options, and I will talk about those. I do want to point out one thing, though. If you want CRD isolation, which is a bit trickier, CRDs are global objects. If that's something you do want to look at, you should definitely check out vCluster, as you can implement that without breaking the bank. Anyway, let's look at some of these options, starting from the left-hand side. So once you've figured out your strategy of if a single cluster is sufficient, or you need a cluster manager to orchestrate your orchestrators, or dedicated clusters, you can then layer on top relevant tooling onto that estate to make it meet your needs with relevant tools to them built in Kubernetes, primitive things, or more complex solutions perhaps. So that was a reasonably long journey. So let's have a recap of something going through that. So Kubernetes works best when you can share things. If you can share things, you can find things easily. However, that sharing is predicated on an expectation that everyone is in the same trust domain. Managing that sharing is much like dealing with a class of toddlers. It's hard and you'll be struggling to establish any degree of fairness. Network resource is similarly difficult to divvy out fairly. And limiting the blast radius of one workload to another in any sense is also hard. In general, security is a constant trade of security and isolation versus cost, complexity, and usability. And finally, a quick thank you to Loft Labs for hosting these 3 sessions with us. If you've not seen them, the previous 2, then I'd consider Daniele's and Salman's talk as essential watching. So please do go feast on those. Thank you so much for your time. We've hopefully got some time for questions. If I don't get a chance to answer it, or if you're not watching this live, then please do drop a line in the Loft Labs Slack, or say hunt me down on LinkedIn.
Awesome. Thank you so much for that. Let's see. We got a couple minutes for questions. If anyone has any questions, you can go ahead and post them in the chat. We did have one. We had a couple of questions, but it was mostly kind of like about vCluster. You know, is vCluster mainly for bare metal development? And I would say no. You can use it on EKS, GKE, AKS. You can use it on pretty much any Kubernetes cluster. So you can do it bare metal, right? You can use MetaLB and have a load balancer do all that, or you could do it in the cloud. Pretty much anywhere you can split up a cluster and make it multi-tenant. All right, let's see. I think we had not a lot of questions, just a lot of people saying hello and checking in and everything like that. We had Salman check in and then a bunch of other people check in. All right, but we'll give it a minute or two for that. I'll do a CTA talking about what's coming up next. And then if no questions or anything like that, then we can head out. And then, oh yeah, so let me go ahead and bring this up. I'm going to share something different. Give me one moment. All right. Here we go. All right. Hopefully everyone can see that. Last time I did this, it didn't come up. Well, 2 times ago, it didn't come up. But next week, we have one more part of the series. It's going to be a workshop, how to build Kubernetes platform with vCluster. And it's going to be Piotr, who is the head of engineering enablement at Loft Labs. You can scan this, or you can go to the website, vcluster.com/multi-tenancy March. And I'll post that in the chat in a minute too. And then also, if you want to join our Slack, here's our Slack information for Loft Labs and vCluster. And if you want to schedule a demo, you can go to vcluster.com/enterprise demo to see more about that. But pretty much, thank you. I'll leave this on here for a minute just in case people want to join. And then I'll also see if anybody asks any questions, and I'll post the vCluster stuff in there. But so, Chris, you say seems like you have a lot of love for Kubernetes, right? Like after watching this, you would say maybe you don't want to touch it for a while again, but
it's often not my first recommendation.
Yeah. So if I'm running a guest book or like a personal family website, I should use Kubernetes, what you're saying?
Yeah, totally. That sounds like a totally proportionate answer for the problem.
All right, cool. So we do have a question kind of about GitPods, which you're talking about that previously. It was difficult, 4 or 5 years ago, someone said to set up. Is it easier to set up and operate now? Are you using it like on a daily basis, or?
I'm personally not, so I wouldn't be able to really answer that, to be honest. I kind of went through looking at the blog post and kind of went through some of the points that they talked about in an abstract fashion, so we had something to talk about and point at it. But yeah, I'm far from being an expert in understanding how Gitpod works, I'm afraid.
Let me plug DevPod too. We have something here at Loft Labs called DevPod that you can check out too if you want. That one's more hosted on your local machine, and it does some of the same things as Gitpod. But yeah, check out DevPod.
And let me do that. It's way better, and it runs on Kubernetes still.
Yeah, and yeah, so it'll bring up it'll run on AWS stuff too. Like it'll bring up a virtual machine and then run Docker and stuff on there. All right, so sorry, I got this new keyboard. And I'm trying to remap. I did not know this. I've been on computers forever, but my friend finally told me remap. Your control control paste to caps lock. I don't know if you do that. Right, like I've never done that before, but I was like, okay, that makes it a little bit easier. All right, cool. So this is multi-tenancy March. We have one more session, like I said, coming up on Monday. So if you want to see the workshop, you can check it out there. If you want to rewatch this video, it's on YouTube, LinkedIn, StreamYard, Twitter. And if you want to, you can post comments on any of those, and we should be able to follow up. But doesn't look like we really have any questions or anything coming up. Chris, do you want to say anything before we head out then?
No, thank you very much for having me. And
thank you so much. And thank you for the presentation. All right, cool. So see everybody next week. And then also, let me plug one more thing, right? See you all at KubeCon, right? Like I won't be there, but a lot of us will be at KubeCon. We'll have a booth. If you want to come see demos, if you want to come like get a book, we'll just have some book signings, stuff like that too. You can check that out. So DevPod is my main tool, super handy. Maybe 3 generations of my own tooling to create dev container-like environments. Yeah, I mean, thanks for that comment. Like, we love to hear it. So yeah, go check out DevPod too. All right. We'll let everybody go. Thank you for joining. And then, like I said, yeah, if you have any questions or anything like that, just post them on any of the various social channels, and we'll try to answer them or join Slack. But thanks so much, Chris. Enjoy your evening.
Cheers. Bye.